Sherman DD, shown here entering the water, is a standard U.S. medium tank modified to enable it to float and maneuver about in any depth of water. On reaching shore, the canvas side walls can be dropped and the main armament of the tank brought into immediate action. The canvas side walls are raised by means of compressed air, which enters rubber tubes spaced equally about the inner side canvas walls. The man in the bow is opening the valve, which will allow the compressed air to flow from two compressed air bottles through a pressure-reducing valve to the individual inlet valves at the bases of the rubber vertical tubes. As the compressed air enters the vertical rubber tubes, the canvas starts to rise, and the metal struts, which add rigidity to the canvas, move out of their folded positions in the bow. The rear canvas wall, as well as both side walls, rise simultaneously with the bow canvas wall. Here again, the struts at the rear are being raised with the canvas. The raising of the canvas walls continues until the vertical rubber tubes are in a completely inflated condition. The entire raising procedure taking from 4 to 5 minutes. The method of starting the inflation shown in this prototype vehicle, namely the opening of a valve in the bow of the vehicle, will be changed in the production model, which will have the pneumatic control valve in the driver's compartment of the tank. With the vertical rubber tubes fully elongated and the canvas side walls in the fully raised position, it is necessary to make the metal supporting struts. This is accomplished manually by snapping the various struts into position. The struts in the bow are being made first here. Next, the short struts at the side are made. A similar pair on the other side, not shown here, is made in the same manner. To complete the making of the mechanical struts, the 4 struts at the rear are snapped into position and the vehicle is ready to take to the water. Were the Sherman DD to be launched from a landing craft for an assault on a hostile shore, the raising of the canvas side walls and the making of the mechanical struts could be done immediately prior to the actual launching. The entire procedure takes approximately 6 to 7 minutes' time. To lower the canvas walls, the struts must first be broken. This is done hydraulically by rotating the hydraulic control operating handle to the 5 o'clock position and squeezing it. This causes the pistons to move on the various supporting struts, and the struts are kicked open. To maintain the rear canvas wall at 1/3 height while the remainder is lowered completely, a special hydraulic valve is closed. The operating handle is then swung counterclockwise to the 2 o'clock position and squeezed, and immediate collapse of the canvas side walls results. The operation of the control valve handle in the 2 o'clock position has opened the exhaust valves in the bases of all the vertical rubber tubes except the 3 short tubes at the rear. Should it be desired to fire at hostile shore groups from the shallow waters approaching the shoreline, the partly raised canvas in the rear would now protect the vehicle from incoming surf without preventing the guns from being elevated, depressed, or traversed. To complete the lowering of the canvas at the rear, the special hydraulic valve is now opened and the main hydraulic control valve handle is again moved to the 2 o'clock position and squeezed. This opens the exhaust valves in the vertical rubber tubes and complete collapse of the canvas side walls occurs. The canvas side walls can be completely collapsed in one operation by leaving the rear air tube valve open and operating the main hydraulic control to the deflating or 2 o'clock position. Complete collapse of the canvas side walls then occurs, the entire operation taking but a few seconds. When in the water, the Sherman DD is driven by 2 28-inch diameter 3-blade propellers, which can be raised or lowered hydraulically from inside the tank. To engage the propellers, the clutch is first depressed. This stops the tracks and the mechanisms which the tracks drive. The propeller plunger hydraulic control valve is then operated. This extracts the locking plungers which have been holding the propellers in the raised position, and the propellers then drop of their own weight. The clutch is released, and the propellers and tracks start moving. The motion of the tracks is thus being imparted to the propellers through the special driven rear sprockets, the ring and pinion gears, and the universal drives to which the propellers are attached. The propeller units have a Spicer universal drive, a standard Ford rear axle bevel gear and pinion, and 2 track tension locking bolts. The standard track tensioning unit has been replaced by a screw-type adjusting mechanism. The rear idler has been replaced by a driven sprocket, which in turn drives the shaft bearing the Ford bevel gear. Steering of the Sherman DD in water is accomplished through the back and forth movement of the propeller units, much the same as is done with ordinary outboard motors. This can be done hydraulically from inside the tank. The hydraulic steering transmitter is located to the right and rear of the driver's seat in the tank. A detachable handle is provided, and this is moved from side to side. This movement sets in motion an arm on the hydraulic receiver unit located at the left rear of the tank, and the connecting linkage swings the propellers. In this way, the direction of the Sherman DD can be controlled effectively from the driver's seat by the simple movement of the hydraulic steering lever, course being maintained with the aid of a periscope or a gyro indicator. As an alternative method of steering, a platform and a long steering lever are provided at the right rear of the turret. The movement of this long lever is transmitted to the same mechanical steering linkage at the rear, which is activated by the hydraulic receiver unit. To raise the propellers, the clutch is depressed, stopping the movement of propellers and tracks. The propeller plunger hydraulic control valve is then operated, and the propeller locking pins are again extracted. The main hydraulic control valve handle is then operated in the 8 o'clock position. The squeezing of the handle again sends the oil pumps in action, and the propellers are raised by the resultant oil pressure. The immersion indicator is located at the rear of the tank. Water at the height of this rubber diaphragm lights a small lamp inside the tank. A gyroscopic directional indicator is provided for navigation purposes. The correct magnetic setting for this indicator can be obtained from an externally mounted compass, which is raised to a vertical position for readings. These readings are projected to a mirror in the interior of the tank. An electrically operated bilge pump is provided to keep the interior of the tank free of water. A toggle switch located on the instrument panel controls the pump motor. The oil pump and motor are located above the bilge pump, and the oil header tank is immediately to the right. An emergency hand pump located ahead of the driver can be used to provide necessary oil pressure should the oil pressure pump or motor fail. Now that these long mechanical explanations have been completed, let's have a practical demonstration. There she goes, gentlemen. And believe it or not, out of that LST has been launched 30 solid tons of armed might, which under a simple canvas cover is steadily moving towards some unsuspecting shore.